The present book is devoted to the theory of thin antennas and its application to antenna engineering. I'll talk about one problem, the story of which solution is described in the book, and the solution itself is obtained by using a rigorous approach. An approximate method of an antenna characteristic analysis, called EMF methods or induced EMF methods, was developed in the beginning of 20th century by Klaskin, Carter, Brown, Pistelkors, and their numerous followers. Rigorous methods of calculation built on the basis of electromagnetic theory came to light later. The greatest progress in this area was obliged to two equations. First equation was proposed by Harlan. In the solving and popularizing of these equations, the considerable contribution was made by King and Aaroni. The second equation is derived and solved by a Russian academician Leontovich and his disciple Levin, the friend of the physicist Landau. Both equations were solved up accurate to the second approximation, and solutions are obtained in explicit form, that is, as a set of known functions. They coincide with each other when using identical expansion parameters. Also, they coincide with the solution obtained by EMF methods, but only in the antennas without losses and in the points distant from the current node. In addition, the solution of equations did not lead to an integral expression for the radiator input impedance. I am proud that I was able to resolve these discrepancies. Small correction of solving Leontovich-Levin equation allows to infer the integral expression for the input impedance, which coincided with experiment and in the points distant from the current node coincided with the expression obtained by EMF methods, or rather with its second formulation. This formulation is based on the concept of oscillating power, which was introduced by Weinstein instead of reactive power having no physical meaning. On the whole, the book is certainly not limited by this example. It presents new methods of antenna analysis and design, including the theory of electrically coupled lines, the methods of complex potential, of the compensation, of the impedance line, of the mathematical programming, etc. New results are obtained. The complex potential method is generalized to inhomogeneous media and is employed to conical and parabolic problems. The theory of electrically coupled lines allows us to analyze problem of multi-conductor cables and multi-radiator antennas. The compensation methods permits creating a weak field area in the near region of a transmitting antenna. Application of methods of impedance line permits to solve the inverse problem of the antenna theory, to create radiator with the required electrical characteristics. I hope that this book will be useful for analysts and designers and students.